Good day, students, and welcome to another series. Today we are looking at trig functions logically, not in a special way, but in a certain way. And just a young reminder, there is a bit more than what meets the eye when dealing with trig functions. So stick and stay with me throughout this session for the benefit of your little treasure of wisdom. And please don't forget to subscribe to the channel if you haven't done that for more mathematics content and NSC content. Let's check. Question 7. It's a national paper for your more information. It's a national paper. I actually forgot the year in which it was written, but it's for metric learners. We are saying in the diagram below, the graph of f of x, which is given by sine x plus 1, is drawn for the interval negative 90 degrees up until 270 degrees. All right, so they are in degrees in actual fact, even though they didn't really put that, this degrees, they must really put that to show that you are working with degrees. But if they don't do that, just know that you are working with degrees. All right. Now, the first question, they are saying write down the range of f. What is the range? The range, we're talking about the minimum and the maximum value of the graph of f. In this case, it's f. Sometimes it can be g. That's why I have to emphasize the issue of f and g. All right. So it's the minimum and the maximum y value of that particular polynomial. In this particular sense, there are myriad of ways to determine the range of f, more especially if they've drawn the graph for you. So the minimum of y value, please get that, it's at negative, it's at negative x, negative 90 for x, I mean to say, which is the y value there is 0, and then the y value here, it's also 0. And then the maximum y value there is actually at 90. So, but we're talking about the y value. We're talking about the y value there, which is 2. So the minimum, it's what? It's 0, and the maximum, it's 2. So the range for this particular graph is going to be in between 0 and 2. All right. I hope that makes an absolute sense. So you're going to write that your range, let me just write it here, is y element of real numbers from 0 to positive 2. Remember that you can also represent this situation as 0 in between, y is in between 0 and 2, so to say. You can put it in that way. Like I said, there are myriad of ways to get this particular interval, for in case you don't know. Let me show you the other way to work it out. The other way to work it out is to have the actual range of sine x. So that is in between negative 1 and then and 1 there. This one is the actual range for sine x. But because now there is a vertical translation of positive 1. All right. So you need to be very careful. You are going to add 1 to this particular range because it's now affected by this value of q, which is 1. So I'm going to say that this is negative 1 plus this 1 here, and that is 1. And then I'm just going to write y in between. I still have my 1 there, so this is 1. I'm going to add this one both sides as 1. So I'm going to put a 1 there. Now, if you look at it nicely, you see that you're going to get a 0 there. So this is going to be 0 in between y, and then 1 plus 1 is clear that it's positive 2. So this is another way of working your range. I hope it's clear as well. It's another way of working your range. The first is 2 marks, so you have to really sweat for it. For sometimes scale is not going to be accurate, so you can work it out, or you can just read the graph and you'll see that the minimum is going to be clear and your maximum as well. Now, the next question, question 2, they are saying show that Sine x plus 1, which is equals to cos 2x, it can be written as sine x plus 1 is equal, into sine x is equals to 0. Okay, let's check that. So I'm just going to write 7.2. We are given sine x. So this is sine x plus 1, which is equals to cos of 2x. So we want to prove that this situation is equals to this one. All right, if you check that situation, each term is in terms of sine x. So that means we need to make sure that if we see identity, we change that to be in terms of sine. So we are going to say to ourselves, this is sine x and then plus 1, and that is equals to, if you observe this one, we call it a double angle of cosine, which has 3 branches. All right. The first branch is that you get a cos squared of x minus a sine squared of x. The second branch is that you're going to get 1 minus a 2 sine squared of x. And then the last one, finally, is twice cos squared of x minus 1. Or if you don't know them, you can go at the back of your paper. You're going to really find that one. So we want the one in terms of sine. So this one has cos and the sine. I'm not going to take that. This one has cos, so I'm trying to do away with cos basically. So I'm going to take this one and say that is 1 minus 2 sine squared of x. Now, you will then say to yourself, let me transpose everything to the left side. Now, you're going to have a sine x. If you transpose this situation, it becomes positive, right? So this becomes a positive 2 sine squared of x, and then 1 minus 1, it's really going to be a 0 there, so you're going to get a 0. Now, it's a quadratic situation. You can really rearrange it properly to say this is 2 sine squared of x plus sine x is equal to 0. You can see that there's a common factor of sine here, which you can take it out. And if you do that, you're going to get a sine x. I'm now going to take a common factor of sine. So I'll be left with twice a sine x and then a plus 1. That is equals to 0. And then you have proven that part, which is sine x. The things they are putting it at the back there, but it's the same situation. You can put it in front or at the back as long as it's multiplication. We call it commutative multiplication, so it's fine. Or you can, if you're not really happy about that, you can say this is 2 sine x plus 1 into sine x. It's the same situation. All right. So now it's a lot of steps, unnecessary step basically. Let's check where you're going to get the marks. The marks is to be able to change that identity to be 1 minus sine squared. And then the other one, it's this one or this particular step. It's the same step, you know. So you can write this one or this one. Let's check the other one, the next question. 7.3. Hence or otherwise determine the general solution of sine x plus 1, which is equals to cos 2x. Okay, that is really an easy stuff. 7.3, let me put it here. 7.3, you get sine x plus 1, which is equals to cos of 2x. You want to find the general solution, but we have agreed that this is the same as this one. So I'm going to then say, therefore, I'm going to have a sine of x plus 1 multiplied by a sine x is equal to 0. It's the same as this one. We have proven it. So don't rewrite this one. You'll be wasting time in the exam. And there's no time. So we want to find the general solution. The best way to attend it is to equate each factor to 0. It's basically your paper 1 algebra. And then you're going to say this is 2 sine x plus 1. It must be 0, or the other factor, which is a sine x is equal to 0. Now observe that you can make sine x the study of the formula here. So it's going to be sine x is equals to a negative situation. That is negative 1 over 2. And then or sine x is equals to 0. You want to get the general solution of this particular one. Please guys, hear me carefully. This negative, you can see I'm putting it in yellow, and then the other one is in purple. The reason for that is because this negative basically tells you where sine is negative. So you can draw that, that diagram of yours. You'll see that sine is negative in the third quadrant and also in the fourth quadrant. However, you need to get the reference angle. And before you do this situation, notice that in the third quadrant, you have 180 degrees plus your reference angle. So I'm just going to write a RF for reference angle. In most cases, you guys write theta here. But I'm going to write x because I see I have x there. And then now I'm going to have a 360 degrees. These are in degrees. Then a minus x for the fourth quadrant. So I'm not going to, if I'm to find the reference angle, I'm not going to punch this negative. You don't do that. No. You can then find a reference angle. To say a reference angle is going to be the arc sine of positive 1 over 2. That is going to give you the reference angle. And if you do that nicely, it's going to give you your 30 degrees. All right, so now your solutions is this one and that one. Those are your general solutions. So you are now then going to say to yourself, let me just do this. You are then now going to say, now x is going to be equals to 180 plus in the third quadrant. So it's 180 degrees plus the reference angle, which is 30 degrees. Please, guys, be careful there. So it's going to give you something there. You get 210, I guess. So this is 210. So I'm just going to write 210 degrees plus the period times k. So the period is 360 degrees, where k is the element of z, where k is the element of integers. Let me just put it here. Now you write, or the other one is on 360 minus. So you're going to write x is equals to 360 degrees minus the reference angle, and that is 30 degrees. All right. So if you type that in your Casio, it's going to give you something there. Please make sure that you use calculator to get answers there, and then you get 330. So I'm going to write 330 degrees there, and then a plus k times 360 degrees, where k is the element of integers. Now I'm going to delete this situation. I'm done with that. I was just trying to explain that part, you know, where I get my answers. So this is the first part. I have to also look at the other branch of sine x. So sine x is equal to 0. Think about it. This is equal to 0. So 0 is always positive. You know, so you are going to say to yourself, where is sine positive? Sine is positive in the first quadrant and also in the second quadrant. So in the first quadrant, it's basically your reference angle. And then in the second quadrant, it's 180 minus your reference angle. So you are going to then say to yourself, let me get a reference angle, which is going to be the arc sine of a 0, which is going to give you a 0. This will then mean that it's going to be equal to your general solution of this part. It's going to be 0, the reference angle. And remember that this one is in degrees. Say plus, and then you get your k times 360 degrees. And then where k is the element of integers. Now, I want you guys to pay attention here. I'm going to say or the other one is at 180 minus the reference angle. So it's going to be x is equals to 180 degrees minus the reference angle, which is 0 in this case. So I'm gonna put a 0 degrees, which is 180. All right. So I'm just gonna have 180 and then plus k times 360 degrees there, where k is the element of integers. In some books, if you read too much, you will see that if sine x and cos x, if they are equal to 0, it basically changes the period. So you're going to say, well, the other way of writing this situation is to say, or x is going to be equals to 0 plus this situation is basically this one. So, but because it is equal to 0, it changes the period. So that is 180 degrees times k, where k is the element of z. Or you can say it's 0 plus 180 degrees times k, where k is the element of integers. It's the same thing. But we want two answers. So you either give us these ones, or you let me just do this here, or you give us this one and this one. We want two of them. So you can give us that one or this one, but this one have to be there as well. I hope I make sense on that problem. So the general solutions here, they have to be 4. It's this one and that one, and then and 1, 2, 3 there. So they make it 4. This one is also allowed to write in the exam. Let me just clarify this thing of the period basically. If you have sine x is equal to 0, we are saying, where is this graph sine x equaling to 0? You see that if you are to draw it nicely, it's going to behave like that. So let me just do this. So it's going to be equal to 0 at 0, at 180 there, and 360 somewhere there. Same thing here. Now we are on the positive scale, so you're going to have those guys there. That is 0, 180, and 360. That is why the period there is now changed to that particular situation. Now, we look at the next question. What are they saying? They are saying that use the grid on the diagram sheet to draw the graph of g of x, which is equal to cos 2x for that scale. So you want to graph cos 2x. Let me erase this one as well as this one. I want to graph y equals to cos of 2x in this scale here. So I'm not going to struggle. I'm going to say to myself that I'm going to start at the negative 90. I'll say cos of 2 times negative 90. I'm going to get the y value there. Let's see. I'm just going to use my calculator. So it's cos 2 times negative 90. I'm going to get a negative 1. So it's basically at this particular point. And then now you erase negative 90, you put negative 45 at this point. You put negative 45 degrees, 2 times negative 45. Let me also change it in my calculator here. Negative 45. I'm getting a 0. So we get a 0 there. And then when x is 0, I'm getting a 1. So there we go. We get a 1 there. And then for 45, it's going to be 0. Then for 90, it's going to be at negative 1. And 135. So it's cos 2 times 135. You get a 0 there. And then for 180, it's marked 360. which is 1, I believe. So 180 is going to be 1 there. And then for 225, let's check that. 225, we get a 0. And then for 270, the last one, we get a -1. So it's a matter of connecting this situation there. Make sure that you draw it nicely, this one. Yeah. This is how you draw this graph. And be careful with your maximum and minimum. I need to draw it. Let me redraw it properly so that it doesn't catch up with me. There it is, there. I go to this point and also come to that point again. Cool. You must draw it properly that side. All right. And then this is what we have. I'm not drawing it nicely, but you must draw it nicely. I'm used to computational stuff, so I see it's very ugly, but I hope you get the knowledge of that. I think Zamukuhle will agree with me there. Now, let's check the next question. So you get 3 marks for that, basically. Now they are saying determine the values of x for which f of that and g of that are going to be equal in the interval. Okay. So let me write it here. F of x plus 30 degrees is going to equal to x plus 30 degrees. So we are basically shifting these two graphs to the left by 30 degrees. So it's basically your horizontal translation to the left. You know, left or right, it's horizontal translation. Vertically, it means upwards or downwards. So this one, it's on the x-axis, not on the y-axis there. So let's check. But before we do that, let's check where is f of x equaling to g of x. Let's check this one, because we are now going to move them by 30 degrees to the same direction, which is left. So let's check where they are equal. And where they are equal, we found them. It's basically these points. This is where they are equal. Remember, this is f and this is g. So where they are equal, you have got your general solutions to really verify there. But let's check from the diagram as well. They are equal at what? Let me go up there. Okay, sorry about that movement. Let's check where they are equal. They are equal at 0 and at this particular point, which I don't know the value of that for now, the x value, but we can find it, don't worry. And then where they equal, they are also equal at 180 there. This is where they are equal. And they are also equal at this particular point. That's where they are equal. So let's check from our general solutions. Let's check that. That was 210. And remember, they are now also giving you the intervals. So that means these things of integers is going to work now, right? It's going to work now to say we're going to let k to be 0, plus or minus 1, and plus or minus 2. Let's test with those ones. So I'm going to take k as 0, and I'm going to get 210. I'm going to get 210 if k is 0 at this particular point. So it means in the graph it's equals to 210. Here is 210. So I'm fine with these 2 points. Oh my goodness. Okay, I'm fine with these 2 points. It's 180 and 210. Now here it's also 0. I just need to get this other one as well. So there are four values of x where these guys are equal. It's at 0 and at this point. But this other point, let's check this one. When x is I can't take positive 1, because if it's positive 1, I'm going to get a very big number here. Let me take negative 1. If I put a negative 1 there as k, I'm going to get 330 minus 360, which is a negative 30 degrees. So it means this is negative 30 degrees. So we have now 4 points where they are equal: negative 30, 0, 180, and 210. Okay. Now, we are going to then say these guys that are equal when x is 30 degrees, and then also at 0 degrees, and then also at what? At 180 degrees. They are also equal at 210 degrees. So now I'm going to move these points. I'm going to move these points to the left. This is the meaning of this particular. Let me just write where we are, basically. So this is 7.5. This is actually 7.5. So let me recopy that and just put it here. So I'm going to move these points to the left by 30 degrees, because think about it. If you are to move these graphs to the left, that means this side, you are moving it to the left by 30 degrees. It means that this point is going to move this side by 30, and then this one as well, it's going to move by 30. Please pay attention there. And then also this one is going to move by 30. And then this one is going to move by 30 as well. So already you can see that you can expect our values for at least this one. You can see it. It's going to be part of that. And then this one, we don't know it. But we know that we can find that value very easy. Whatnot. So we're also going to get this one of 30, and then this one, it's I don't know, but let me show you how to really get that, because we are moving it to the left. We are moving to the left, so we are going to subtract 30 degrees from those points. So now I'm going to say minus 30, negative 30 to the left. So that is negative 60 degrees. 0 degrees minus 30 degrees. That is going to give you minus 30 degrees. And then 180 minus 30. You get 150, I guess. And then now 210 minus 30. You get what? You get, I don't know, you get a positive number. So that is 180 if you subtract 30 from there. So this is where the graphs are going to be equal. It's minus 60, minus 30, and 150, and 180 degrees. So you can go and really look at the diagram. So you will see that this point is really going to be at negative 60, that we got it, because it moved from the origin to the left by 30 degrees. So that's why you get that 30 as well. But you saw how I got them algebraically. And then this one is the one we got as 150. So that is 150 degrees. And then 180, we got it from 210 to 180. It's basically, from this particular point here to this side by 30 units, it's 180. So it's those values that I got here. Yeah, these are tough questions in the exam. Students, they really battle with them, but this is how you'll go about them. Actually easy. I think we are almost at the end. At least the last question. They are saying, consider the following geometric series where you get 1 plus 2 2 cos x plus 4 cos squared of 2x. So let me really copy this one down and work it out. Consider one, it's a geometric series, so they are taking back to paper one basically. 1 plus 2 cos 2x plus 4 cos squared 2x. They are saying use the graph of G to determine the values of x in the interval 0 to 90 degrees for which this series will converge. Okay, so let me have 7.6 here. You are given 1 plus 2 cos of 2x plus 4 cos squared of 2x. But it's a geometric series. Okay, so what do you know about geometric series? What we know is that a series will converge if our r is between -1 and +1. Think about it. If you have a 1 plus 3 plus 9 plus, that's a geometric series. So if you are to find your r, it's going to be the ratio between the two consecutive terms. So that is going to be 3 over 1, and that over that. You guys know how to get your r, something like that. Okay? So we are going to find the r of this geometric situation. Let's see. We are going to then say, well, our r is going to be t2 over t1. So our t2 is this one. So that is a 2 cos of 2x divided by 1, which is equals to 2 cos of 2x. Is the value of the common ratio between two consecutive terms in your paper one. I hope you are also inclined with that. So we get the value of r. We get the value of r to be this one. So we are now going to say, well, this series will converge if -1, you've got a 2 cos of 2x there, and you've got a 1 there. So this series will converge if your r is in between -1 and 1, and your r is this one. And then you divide everything by 2, just to make a general sense there. You get a -1 over 2, and then you get a cos of 2x, you get a half there. So they are saying use the graph of G to determine, let me check the question. Use the graph of G to determine the value of x for which this, in that interval, from 0 to 90, for which the series will converge. Okay, so what I will then do is, I can look at algebraically from the graph, or I can solve it. There are myriad of ways to attend this one. So what you can do is, you can take the arc cos on both sides. Notice that if you take the arc cos of negative half and the arc cos of positive half, you are going to get different values. But if it was sine and tangent, it was going to be the same values, but different in sign. This is influenced by a cos of negative theta being positive of cos theta. We don't have negative angles in cos, all right? But for sine, if you remember your fundamental rules, your sine of negative theta is going to be negative of that angle. And so is the tangent. So with this one, it's going to be a bit tedious. Check. The arc cos of negative half. In actual fact, you can, because cos behaves specially for your general solutions, you can say plus or minus the arc cos of that, or you can type with that situation the whole the negative itself. But for general solution, you don't really type that negative. But for the benefit of the doubt, you are going to get a arc cos of this situation, which is going to give you 120 degrees. And then that is going to be 2x now, if you take the arc cos. of 2x. And then now, if you do that, it's different from this value. You're going to get a positive 60 degrees. But it doesn't make any sense here. So now you're going to get your 60, and then your 2x, and then you get your 120 degrees. You can now divide throughout by 2, you know, and then you're going to get, divide by 2, you're going to get 30 degrees. Your x, that is going to be, that is 60, I guess, degrees. Yeah, this is going to be your solution. And then, but because they are very specific, that you can use your graph of G. Think about it. I want to show you something analytically. Check. This is this was the graph of G. So it's more like a Y. You're going to check the graph, of course, where it's in between -1/2 and the +1/2. Please don't copy this down. I want to show you something. So this is the graph. This is Y. Remember that. It's the cos graph, which is Y. It's in between -half and half. So you're going to look at your graph, like they said. Use the graph of G, where it's in but now you're going to look at from 0 to 90 in a graph of G. So let's go to the graph of G and observe that. So I'm just going to draw this line. This is the graph of G. And then that's the graph of G then, from 0 to 90. So I'm going to look at this region from 0 to 90. And then this is from 0 to 90. My answers are going to be here. If you want to look at it graphically, check. And then let me do this. Check now. And then I just want to this technology thing. So you're going to check where the half is. And then let me make it black here. Let me have the half here. It's the -1/2. And let me have a +1/2 here. So I'm going to go here up until I reach this graph here. This is the point. And then I'm just going to go here up until I reach my graph here. So if you want to check here nicely, this graph here, this portion, it's in between -half and +half. So it means your answer now is going to be somewhere here. And if you go down to the x-axis for the x value, you'll see that I'm not drawing really nicely this one. Okay, cool. So it means you're going to get your solution somewhere there and somewhere there. But you see that this is going to be 60 and that's going to be 30. But this one is basically your assumption, you know. But if you look at it algebraically, the way I solved it out, and then it really give you those values quite nicely. Or you can really look at the graph the way I was trying to show you, where it's between -half and +half. All right. So this is how you're going to attempt this question. Thank you very much for watching. If you have any question, you are more than allowed to comment to the question. I mean, to the paper itself, how I solved it out.